And it turns out the official introducers are both out of town, so I am now the official introducer for today. And we'd like to welcome Jennifer Jae Gutierrez, who's the Executive Director of the Permanence Institute, what we always call the IPI. And she came from one of my favorite places, which was the Center for Creative Photography in Tucson, where when I was in grad school at University of Arizona, I spent many happy hours just dozing around the museum part of that. She established the conservation department there. And she did research in the archives that informed essays on Robert Heineken's word processes and materials associated with Eugene Smith's Big Book project, which I don't know anything about. But and she now has affiliated faculty status with the Art Conservation Department at the University of Delaware, which of course is famous for conservation work with its proximity to Winterthur. And she taught undergrad and grad level courses in preventive conservation, conservation ethics, and the conservation of photographic materials. And she served as associate director of the Winterthur University of Delaware program in art conservation. So she's going to speak to us about the research and education of IPI, and we are hoping to establish a firmer connection with some of the work we're doing in preserving, in image processing of historical manuscripts. So really looking forward to this.
Super. Thank you, Roger, for that. Thank you guys for the invite to be a part of this lecture series. And thank you to all the first years that I had the pleasure of having lunch with. I enjoyed our conversation and your questions. You got to hear sort of the first part of what did I do before coming to RIT, and this is going to fill in what am I doing now. So the focus of my talk is current research and education initiatives at the Permanence Institute, but I am going to sort of go back and start with the very beginnings in the history of IPI. My goal is to give you a good sense of what it is that the lab does, the kinds of research questions that we're answering for the preservation field, and highlight some of our research milestones that have had the greatest impact on the preservation of image collections and library and archive materials, focusing on activities that are still present in the lab today, and to current projects and sort of where we are and where we are going. My secondary goal in any presentation I give to a non-preservation group is to hope to inspire someone in the audience to be an advocate for preservation in some way. If not through your own endeavors, through supporting your own favorite cultural heritage collections, being aware of material collections in need, and what exactly goes into preserving our material culture. Okay? I would welcome questions along the way if you have any that come up. I'm happy to have this sort of be more informal and like a classroom setting. So starting with the history of the lab, and can you hear me in the back as I wander a little bit? Super. So in the early 1980s, members of the Society of Photographic Scientists and Engineers began talking about the need for an objective research laboratory that would conduct scientific research on the permanence or the longevity of imaging materials. So this is an excerpt from one of our sort of founding documents in the IPI archive, where a member of SPSE from Kodak at the time who was advocating for this lab notes that the question of permanence has naturally lagged the innovation of new imaging techniques and materials. You can see it's 1984, and he goes on to say, we know more about monochrome image processes than we do about color, more about color than we do about electronic imaging. And you could almost excerpt this from a letter today. The same issues hold true. Though we know so much more about the permanence and the preservation of these image materials, there still is a lag in caring for knowing how to preserve long-term the newest imaging technologies. So having some of these advocates at SPE were of course Rochester-based, and they encouraged that SPSE reach out to RIT in the interest of starting a collaborative lab, and at that point RIT agreed to this collaboration, and IPI was started in what was then the School of Photographic Arts and Sciences. So we were officially founded in December of 1985, so we're just over 30 years old at this point. And you can see this is an excerpt where the dean of the School of Photographic Arts and Sciences at that time said this is an initiative that will help RIT become a major force in photographic preservation. There was some research happening here. Our founding director, Jim Riley, was already doing research on the permanence of silver-based image material, and he became director of IPI up until his retirement in August, when I started here in April, so we had a slight overlap. I'm only the second director of IPI, given its history. So we're in quite a transition here. So I want to highlight these two words that both men call out in describing what would the goals of this new lab be: permanence and preservation. Permanence, of course, has to do with the longevity of materials, but mostly based on inherent features. What are the characteristics of those imaging materials? Though we have spent quite a bit of time researching the permanence and the stability of imaging materials, the ultimate goal has always been to understand and inform how to preserve image materials. So how to conduct scientific research that results in easy to apply resources and tools that can be used by collecting institutions to preserve their image collections. And over time, and you'll see this progression in the talk today, our research has expanded to impact beyond imaging materials to really any kind of cultural heritage collection, given the environmental management studies that we're currently engaged in. So I'll take you through that transition. The lab is about 7,000 square foot space in Gannett as part of the College of Imaging Arts and Sciences. And here are some of the spaces to give you a sense of what happens in the lab. We have a microscopy and photography lab where we're examining objects primarily from our study collection. In the lower right, you can see an image of the study collection storage area in relation to a classroom. This is predominantly vernacular photography, and the images, the objects imaged in this presentation today are all taken from that study collection. So if ever you have any need for research in an analog photography collection, please keep us in mind. We're actively using it for research, but would welcome other people on campus accessing this collection as well. We have, I can't say every photographic process, but a wide range from salted paper prints and daguerreotypes at the beginning to digital output today. The incubation lab is where we have about 30 to 40 ovens that we can do temperature and relative humidity testing in, what's called accelerated aging tests, and I'll get into that a little bit more detail later on. You can see some samples here in the ovens. By exposing them to temperature and relative humidity changes, we can assess what sort of estimate lifetime expectancies in certain conditions for different imaging materials. I'll give you guys some examples. In the upper right, then, you can see the pollution lab. This is where we can do tests with impurities in the environment. Ozone is a major concern for digital output prints, and so that's been our primary research area with pollution. And then in the lower left, this relates to our education activities, our webinar classroom. We found that though we've always done hands-on workshops, as people are more and more busy and travel budgets for professionals are shrinking, there's a real niche for webinars and online content that, especially if you record it so that people can come back to it at any point at their convenience. So we have several initiatives in that regard currently going on. So what are our main areas of activities? These really haven't changed since the lab was founded. The lab was founded to do, again, scientific research on the preservation of image materials, to be a resource for students on campus, and to be an information resource for the preservation community. And that hasn't altered in almost 35 years. So we continue to focus on image and print media stability, so analog photography. Environmental management is key when you're talking about preserving collection materials, and in recent years, our focus in that regard has really been on sustainable environmental management. So how can we get HVAC systems to function in a way that they're efficiently creating ideal preservation environments while also reducing energy use and energy costs for institutions? So if you're committed to caring for a collection indefinitely at specific environmental conditions, how can you do that in a sustainable way? So we have consulting services in that regard. In terms of education and training, I mentioned webinars have been more and more focused in recent years. We also continue to do hands-on workshops where we travel with that study collection, teaching process identification and general preventive care. Also publications, and I'll talk a little bit later about our web-based resources. Again, we're sort of moving towards more online resources because you can update them as new research results are coming in, and also they're widely accessible globally as long as you have access to the internet, which is not always the case for collecting institutions. And then finally, how are these activities supported? Well, we're fortunate to be supported by grants in large part. Over the years, we've had significant funding from the National Endowment for the Humanities and the Institute of Museum and Library Services and the Andrew W. Mellon Foundation. But we also have a variety of products and services that we offer that are self-generating revenue to support these activities as well. And some of these will become apparent as I go on. So who is our audience? Primarily our audience is caretakers, collection stewards in libraries, archives, and museums, nationally and internationally. So this information comes from a 2005 survey called the Heritage Health Index. This was the first of its kind. It was an attempt to condition assess our collecting institutions' condition nationwide. And you can see at that time they were estimating there are about 31,000 collecting institutions and 48 billion collection items in a variety of sort of large bucket categories. You can see digital materials, they were estimating 9 million based on the survey results, and I'm sure that has gone up significantly in 12 years. All right. But in terms of the other hard copy, tangible collection materials, those numbers might not be varying too much at this point. So as I mentioned, the lab was founded in 1985, and our earliest research really focused on image stability of silver image material. Silver image material is the dominant photographic final image material from the reign of Queen Victoria in the late 19th century to the late 1960s. The first US president we see really photographed in color more than black and white is JFK. So it's a good way to sort of remember that transition. Color imaging technologies are introduced before that, certainly in the 30s, but they're cost prohibitive to sort of be used widespread really until the 60s. And so in terms of fine art photography, silver gelatin fiber-based printing remained the standard through the 20th century. And so of this short history of photography, most images, be it them on film supports or paper supports, consist of silver image material. So what are some of the issues with silver image material? As a photograph conserver by training, that's my background, I had to include at least one photographic cross-section for you all. If you're not aware of that laminate structure that exists with photographs, so these are all vernacular photographs, again, taken from our study collection and that have been imaged on Graphics Atlas, one of our online resources. You can see the variety of image tones for silver gelatin prints and some of the deterioration problems that we see. So yellowing overall, the gelatin binder. I think you can see in the darkest image areas, those high density areas, where there's a bit of a bluish haze, okay? This is called silver mirroring. So I refer you to the cross section here. This image in the upper left is, if I were to take an image of the edge, right, of a photograph, then you would see the stratigraphy of that photograph. The bottom layer, this sort of weavy, semi-translucent layer, is cellulose. That's the paper support. That second layer, that bright white layer, is a mixture of pigment and gelatin. It's a barium sulfite and gelatin mixture. Coated over the paper, it evens out the paper, it makes it nice and smooth for the final image layer. And it also makes for bright white highlights. Instead of the color of the paper being the color of your photographic highlights, the color of that bright white varietal layer is what you see in the highlight areas. Then we have a very thin gelatin coating, and within that gelatin coating, there are small filamentary particles of silver that record the image content. This is an image of Walter Clark, who started the first photograph conservation lab at the George Eastman Museum. So just to sort of reiterate, in these areas where I have no silver image material, I'm seeing the color of the gelatin and the color of that bright white varietal layer. In the darkest image areas, some of these caps, Walter's glasses frames, there are a lot of silver bundles. And in the midtones, there are fewer bundles. So we get sort of a gradation of color from high density to low density, white to black. All right. So what we're trying to preserve, when I'm trying to preserve a photograph like this, or any of these photographs that you see pictured below, is all in that uppermost layer. So if you had the experience of handling a black and white silver gelatin photograph. And you know, they're not extremely thick. You can imagine how thin that uppermost layer is. It's very vulnerable. These silver particles, silver is not a noble metal, so it does tarnish. It's susceptible to tarnish with pollutants. That's what we're seeing in this going back to this deterioration in the high density areas is in situations of high relative humidity and the presence of pollutants. Individual silver ions can migrate away from these silver bundles to the surface of the gelatin layer, and they are then exposed to whatever's in the atmosphere, and they can tarnish, just like a silver tea set would, or any kind of silver object would tarnish. And we get this bluish haze. It is reversible through treatment, but this comes down to ethics. I had some good ethics questions during the lunch session. Whether or not you would want to reduce that, it is original image material, can be visually disturbing, so you sort of balance removing original material with has it disrupted the original intent of the object. I'll try not to get too much into treatment, but as a conservator, I do tend to go that way. So a lot of work early on understanding what are the vulnerabilities of silver image material. And as that work proceeded, it became sort of a keen awareness that within collections, it wasn't just the quality of the materials that the photographs were made out of, but materials that were adjacent to them that was causing deterioration. So one of IPI's earliest, if not the earliest, research questions was, is there a simple and highly sensitive test to determine if enclosures are harmless to photographic prints? How do we know whether or not this envelope or this sleeve is going to cause the photograph to deteriorate? Because we were seeing photographic deterioration caused by enclosures. And there have been several attempts to create standards leading up to this, so it's not the first time that this question was addressed, but it was IPI that defined what became the photographic activity test. It became an ANSI standard in 1988, and then an ISO standard in 1991. It remains ISO standard 18916 today and was most recently updated in 2013. So we continue to do this test for countries around the world annually. This is part of our testing services. Essentially, the test involves putting whatever material is being tested. It can be the paper of an enclosure, it can be the cardboard of a box, it can be the adhesive of an envelope, in direct contact with a colloidal silver detector. And these are very small silver particles, so they're more sensitive than filamentary silver particles. And with simply a fixed photographic paper, they're incubated at a high temperature, about 158 degrees Fahrenheit, and high relative humidity, 86% relative humidity, for 15 days. And if there's any change to the detector in comparison to a filter paper also put in direct contact with a second set of detectors, then the material fails the photographic activity test because it has caused change. If there's no change to the photographic detectors, then the material passes. And so if you look through almost any archival catalog on housing materials for photographs, you'll see a reference to passes the PAT. That's a reference to this standard. Note that if you're testing an envelope and that envelope has adhesive that holds the seams of the envelope together, both the adhesive and the paper have to pass the PAT for the enclosure to pass the PAT. Okay. So, yeah, please.
That 15-day acceleration, what is that supposed to represent in average time?
Overall, right. So part of refining this test, as I say, there's this process of what's the best test, was trying to figure out what average natural decay periods were for image material and for paper supports. And so they did a series of tests at different temperatures and different humidities that would cause certain changes to the detector and sort of represent natural aging to the best of our abilities. The issue, it's tricky because not all deterioration mechanisms, some deterioration mechanisms are temperature specific, some are humidity specific, and some sort of require both. So you can't isolate them in this accelerated aging. But this is something that IPI sort of spent time on with color too and with film and making correlations with the Arrhenius equation to sort of extrapolate out what can we predict as sort of the curves of the natural aging. So this excludes things like other risks, external risks like mold growth, high pollutants, things like that that also influence decay, but just typical natural chemical change due to temperature and humidity.
But if I get something that passes the PAT that's been tested for 15 days, does that mean I should assume it's good for a year, for 30 years?
Yeah, you should assume it's good for, I would say, 50, 100 years. It's always, because it's tested against the filter paper too. So there's a detector with filter paper, two detectors, filter paper detector, and then your test material detector, your test material detector. And so filter paper is the sort of marker of like, this will do no harm. And that's what you compare. So there might be some changes to the silver that are natural aging in contact with the filter paper, but that's why you do the control and compare. If that makes sense, yeah. Because again, the silver is very sensitive. But they were finding early on when they were starting with filamentary silver, which are the morphology of filamentary silver is significantly bigger. Like I was going to exaggerate, and I am obviously exaggerating, like filamentary silver to like photolytic silver. So if we use sort of the wink link colloidal silver, which is even smaller and formed differently, it's the most sensitive detector to apply to all of these silver image materials. If that makes sense. Okay. Super. So then when we get into the 1990s, the lab has sort of focused on image material for prints and negatives in terms of black and white, and enclosures, and we begin to shift to the permanence, the longevity of plastic film bases. So this is where I think we've made the most significant contributions in the 1990s. You can see here an example of an early 20th century cellulose acetate negative that is in about stage 3 deterioration. So there are essentially 3 plastics that photographic negatives are made on. The first plastic is cellulose nitrate that's used into the 1950s for still and moving images. Even though in the 30s we know that it is highly flammable and has storage risks, significant portions of our film heritage have been lost to nitrate fires because they are very violent fires that are self-perpetuating. They're difficult to extinguish because of the gases that the fire itself creates or keeps the fire going. So cellulose nitrate is replaced with cellulose acetate, which is referred to as safety film in comparison to cellulose nitrate, and then eventually by polyester film, which is the most stable. But cellulose acetate has these sort of known stages of deterioration. As I say, this is about a stage 3. You can see, I hope, in the image on the top, it's again a silver-based image, so the same as the prints that we were looking at, but same image material. It can mirror as well, so I hope you can sort of see that bluish sheen and the ripples in the image material that have been created as the plastic is losing plasticizers and shrinking. And so this form of deterioration is called channeling. So IPI is beginning to look at, okay, we have these known stages of deterioration. Here you're seeing examples of deteriorated acetate and deteriorated nitrate. So we see that the loss of organic dyes in the slides in the upper left, the formation of anti-halation dyes in this sheet film. So a dye that was initially colorless and put there to control how light goes through the negative. In an environment of high acidity, it forms a color, a dye that we can perceive. And so we start to see blue blotches or pink blotches. This image here in the lower right is advanced deterioration of cellulose nitrate, where again, the acidity being caused by the film deterioration causes a local environment of high acidity, becomes so high in mass level that the gelatin begins to liquefy. And so that the negatives get tacky and they stick together. At this point, you can't digitize, you can't handle these negatives safely. You've lost the image content. All right. This deterioration, this plastic deterioration, is inherent. It will happen at room temperature. Most nitrate film, though it has this fire risk, tends to be more stable than cellulose acetate. Cellulose acetate can be in advanced stages of deterioration in just 40 years. So many collections have addressed these needs. We'll talk about sort of how, but collections that haven't are still experiencing loss of our 20th century film-based images. So next question, this is sort of highlight, can we quantify the acidity level of cellulose acetate film in collections? So this is again trying to get at how do we conduct scientific research in the lab and create tools that collection stewards can use in the field to better care for their collections? And the answer is yeah, we can, because there are distinct levels of acidity that follow this distinct deterioration problem. And we know that when we get to about 0.5 milliliter per gram acidity, which will be a level 1.5 in these AD strips, that's where what's been sort of a slow and steady form of deterioration hits an autocatalytic point and the film begins to deteriorate faster. So through developing these AD strips, they're so named as acid detecting strips. They're acid-base indicators. As they absorb acid, they change color from blue to green to yellow. And they're sold with a pencil that marks these colors. So you can put these strips in direct contact with your film in storage and assess what the acidity level is in the collection environment. And you can get a sense of how close your film is to this autocatalytic deterioration point. Do you need to move it to a different storage environment sooner than later? Also, once you've moved your film to a different storage environment, you can monitor that storage environment to ensure that your film isn't still actively deteriorating. So the higher the level of acidity of your film before you move it to cold storage, the colder you need to make it. As I stated earlier, the deterioration of film is predominantly temperature driven. Relative humidity has an impact, but it's mostly temperature driven. And so the only way to sort of postpone and inhibit this deterioration is by putting collections in cold storage. And when I say cold, I mean frozen storage. And so if you take a look at this chart from one of our MSQRs, which I brought a copy of, sort of a storage guide, you can see that really best practice if you want to preserve nitrate and cellulose acetate collections is to store that film at 32 degrees Fahrenheit or cooler. Certainly, if your film is highly deteriorated, because the colder you get it, it sort of slows everything down. Oftentimes when I'm talking to the public, I'll talk about, how people will tell you that frozen vegetables are as fresh and nutritious as, or not fresh, but as nutritious as fresh vegetables, right? What happens? When you freeze things, you slow down deterioration processes. And essentially it's what you're doing when you would put film in cold storage. Don't put it in your freezer though. I actually have had that question. This is not next to your ice cream. So you see, we need cold storage for the cellulose film bases. But then you sort of see this change. What's happening here? Whenever we're talking about what are the best preservation conditions for objects, we have to consider all of the materials that make up an object. So polyester film, polyester is pretty stable at room temperature. It doesn't require cold storage. So you can see that you can store black and white polyester film at room temperature. That's acceptable. It meets the standards. The plastic isn't deteriorating. The gelatin isn't deteriorating. The silver isn't deteriorating. Right. The difference between color polyester images and silver is the organic dyes will go through thermal deterioration. So they also have to be put into cold storage, as well as the cellulosic plastics. So here, this emphasis is because of the image material, not the plastic support. You see the distinction.
Do you know the mechanism for that?
For
Why the
organic
why
dyes?
Organic dyes would be temperature.
They're very complex molecules in these photographic structures to keep them in the layer that they start at, and they're active at room temperature and begin to deteriorate. So it's a sort of like, how are things moving around at different temperatures? Because color, so the stratigraphy of a color image, subtractive color image, has 3 different gelatin layers, one for your cyan image material, one for your magenta, one for your yellow. And part of trying to figure out sort of how to get the best clarity of images early on and throughout that research was, how do we keep these organic dye molecules in the right layer so they're not mixing and moving around? So they're quite complicated structures. Okay, so then we're up to the 2000s. And here, so what has the lab been doing? We've been looking at image stability, we've been looking at enclosures, what's the impact of adjacent materials, and then also understanding film bases and the importance of environment. And the lab makes a shift to really emphasizing environmental controls, environmental management. And interestingly, the field of photograph conservation, is fairly young in the 1960s, 1970s. So as that field is maturing, so is the Image Permanence Institute. And both the lab and the field are sort of transitioning to an emphasis on what we call preventive conservation. When you're caring for large collections, the CCP I just came from has over 100,000 fine prints and an estimated 5 million archive objects. These are a lot of objects for one person to try to care for. You can't care for them individually through treatment, but you can care for an entire collection simultaneously through proper storage environment, right? So if you have proper temperature conditions, proper relative humidity, reduced light levels, reduced pollutants, you're caring for everything in that storage space simultaneously. So we really began to focus on new questions about environment, like what are the tools that cultural institutions need to monitor and analyze their environmental data. Keeping in mind that some of these institutions will have trained conservators, some will have librarians doing this work, archivists, collection care staff, collection managers, sometimes facility staff take on this role, so a wide range of audiences with professional background. And we developed what initially started off as a software program, but now is a web-based tool called eClimate Notebook. And collections can use a data logger that we sell or any other kind of commercial data logger that records temperature and relative humidity at set intervals, typically every 15 to 30 minutes throughout the day. Download that information regularly, either monthly or quarterly, are pretty standard. Put it into eClimate Notebook and see what the trends are, and then also use the preservation metrics in eClimate Notebook to see, are there risks associated with these environmental conditions? Are you at risk for mold given these environmental conditions for a set period? Are you at risk for chemical change or metal corrosion? So we find that these tools are useful to people caring for imaging collections, but really any kind of cultural heritage collection. It can be natural history, it can be archives, libraries, it can be fine art museums. Everybody has an environment that they're storing their collection in, and if you're monitoring it, analyzing it, and then making changes based on that analysis, you can do a lot of good for the longevity and the preservation of your collection. So a major focus for the lab in recent years. And that takes us to our current decade, where we've focused a lot on online resources. I'm going to show you some links to those. Doing more and more field research. This is a project that was done in collaboration with the Wall Center here on campus to monitor collection materials in their storage environment. OpenStacks are interesting. Anytime that you have collections that have to be kept at human comfort, that's a challenge because human comfort is not the same thing as collection comfort. And so libraries really struggle with this. And what do? Do you isolate collections? Do you put things in annexes where they have to be retrieved? Special collections rooms, things like this. So these are our three sort of web resources. In addition, our website is really mostly focused on IPI information, but these websites sort of highlight the areas of research we've been doing. Graphics Atlas is sort of a connoisseurship and identification tool for print and photographic materials. So it starts with print processes pre-history of photography and then goes up to digital output. And essentially what you can do is sort of explore overall images of objects and detailed photomicrographs of images of objects to compare to, I have this photographic process, I'm not sure what it is, therefore I don't know how to catalog it, I don't know what the ideal environmental conditions are, I'm not sure what display conditions are appropriate, how do I identify this? Graphics Atlas will help you do that. You've got known comparisons to look at with your unknown. That's one of the primary goals. eClimate Notebook, I just talked about a little bit, that's an environmental management resource, and the DP3. For a little over a decade, we've been doing research on the longevity, the stability of digital print processes, which I'll talk about a little bit more shortly. This is challenging. Photography, imaging has changed so much in recent decades. So where I can say, from the 1880s to 1980s, beyond that, if you're talking fine art prints, people are making silver-based images, gelatin, silver, paper. We can sort of make general sweeping guidelines for how to care for those materials. When you say digital prints, you could be talking about a whole host of supports, dye-based image material, pigment-based image material, super coats, no super coats, coatings applied by the photographers, it's much more challenging to generalize how to care for those materials. But we're working on it. So in conjunction with the Graphics Atlas, we're in the middle of a education and training project that is allowing us to we've added new content to Graphics Atlas in terms of how to identify these various photographic processes. And we're doing hands-on workshops across the country and webinars, 6 webinar series. It started in September, goes through February. It's essentially the same content as the hands-on workshops, but in 6 increments. Offered these webinars. This has been the most successful webinar series we've offered to date. The first webinar in September had over 650 attendants from 29 countries. And the numbers might even be a little bit off, because for instance, we received an email from colleagues in Washington where 1 person registered and 10 people sat in on the webinar together. So we don't even know really how many people. We know 650 people logged in and participated. So it's tremendous. And I think this is going to be a trend. Why? Because the people that understood these materials, that used these materials, the makers of these photographic processes that have become obsolete, there are fewer and fewer of them. And people are trying to care for these collections still. They need to care for these collections, but they're not sure what they're looking at because they haven't had any darkroom or printing experience. And so they need the connoisseurship skills to identify what's in their collection, understand what's in their collection, understand what might be coming in. So this will be, Graphics Atlas will certainly be a resource that we continue to add to and develop in the years ahead. I cited that Heritage Health Index report from 2005 earlier. These are also excerpts that sort of show, I would say overall for the report, the results in terms of what are the risks facing cultural heritage collections were not a surprise, but the predominance of one risk over another throughout collections was unknown. And these are interesting, showing how many institutions might not have temperature control in their storage areas, which is sort of, a little, what do you do when you can't control your temperature? Even more so than that, you might be able to control your temperature, but not your relative humidity. So with this focus on environmental management, what can we do? We kind of know the basic guidelines of what are the risks for typical collection materials, but when we're trying to help institutions that can't control their environment in both ways with their mechanical systems, how can we give them additional tools or additional understanding? So this has been a question that IPI has asked in different ways and done research into, I'd say, in many different configurations over the years. How do enclosures influence the effective environmental changes on collection materials? This sort of common sense to know that, well, if you have an object and you put a layer around it and maybe another layer around it, whatever's happening outside of that exterior layer is going to take a while to penetrate that first layer, the second layer, and get to the object, right? So we've done tests on temperature equilibration, on moisture equilibration. Temperature equilibration is pretty fast. It always happens within hours, if not minutes. Moisture equilibration, especially for something like a bound volume, can take weeks, months, years, depending on the materials that the object is made out of and depending on how it's stored. And this, of course, changes its preservation risks. So in one of these configurations, we had a researcher who was creating what was sort of meant to resemble a typical stack of photographs, and then created a cavity for a data logger, temperature and humidity data logger, in that stack to monitor what was happening at the core of the stack as the environment was changing around the boxed objects. So we're doing this in our walk-in chamber where we can control both temperature and relative humidity. So it started out as a project to understand how long is it taking the stack to reach equilibrium at set relative humidity levels. So this would inform seasons. If you are in a hot, sticky summer environment and your RH gets up to 65% for a month or two, let's say July and August, can you buffer or protect your collection materials from that change long enough that they don't feel it because of the rate of equilibration? Okay. What was found, though, interesting information is, because this was in the middle of the collection materials, we're finding that there are moisture changes happening in response to short-term temperature changes. Objects are hygroscopic, they easily absorb and desorb moisture, so they were experiencing moisture changes even before the ambient relative humidity changed. So we're telling collections to monitor their ambient relative humidity, and that will inform what the moisture content of your collections are. We're sort of missing a piece there, this hygroscopic nature of collections. And if you've got a larger volume of hygroscopic materials, it has an even greater impact, because it's almost like having a sponge. Your collection becomes a sponge that can absorb and desorb moisture and contribute to the ambient RH as well as its own moisture content. So we have a research proposal pending to sort of explore this more and look at, if you can only control temperature, you don't have any relative humidity control in your collection, can we give you guidelines for how to adjust your temperature seasonally to control the moisture content at the object level? Not focusing on your ambient RH, but what's really happening at the object level. And hopefully, I'm hopeful that that project will be supported. We'll see. These are some isotherms that show that, yeah, when you change the temperature, the hygroscopic material is going to give off a little bit of moisture. When it increases and when you lower it, it's going to take it in. And so, a guide, in some institutions, it might not be effective or good preservation decision to lower your temperature in the winter months. It would be an energy savings decision, but if it increases the moisture content of your collection overall, you might be putting it at greater risk for faster deterioration. So this is will be exciting. And we're also using an imaging technique right now that we've never used in the lab, using digital image correlation to sort of monitor the response of typical library and archive materials to changes in relative humidity. So oftentimes what you see in libraries, especially bound volumes, most significant damage is handling damage, and then mechanical change caused by changes in relative humidity and strain on the objects as they move around. So thus far, we've done research looking at unrestrained materials, parchment, paper, book cloth, taking images in stereo and then interpreting to what extent they're changing with both increases in humidity and decreases in humidity. We're seeing interesting trends. If you start at 50% RH, which is sort of typical, and it's been a standard for a long time, it's relatively easy to achieve in most environments, and go down and come back. Objects change, but they come back to their original state mechanically. When you go from 50 and you increase and come back, they never quite come back. There's always a little bit of a permanent change. So to what extent is that a problem? Can we use this information to guide collections on, these are your high risk, low and high relative humidity values. Now, unrestrained materials aren't necessarily realistic for library collections though, so we're in a second phase of looking at real library collection materials in sort of typical storage scenarios. You can see the image gets a little funny on the objects. They have to have a random dot pattern on them for the software to interpret what the movement of the objects are. So this is not something that you could do with collection materials that you didn't want to mark permanently. So these are our study collections made of different types of binding in terms of binding materials and the sewing structure, and we'll see what kind of results we get here. And then I'll circle back. This is sort of the last of where are we now. For many years we've been doing research on how do digital prints deteriorate. Right? They deteriorate in a lot of the same ways that traditional analog photography processes deteriorate, but through different mechanisms. So we do have thermal yellowing as well, but we have other forms of yellowing from pollutants, cracking and delamination. Bleed is a problem. The inks can bleed horizontally or laterally, so you have what we call sinking, where the image sinks into the paper support, and you have a loss of sort of image content and clarity. And in recent years, we've been looking at what are the effects of water on photographic prints, leading to a current research project proposal we're working on, especially in light of all of the natural emergencies that we see globally. But certainly it's been in the news this hurricane season, a lot of water damage in areas affected by Harvey and Irma. How do we take what we've been learning about the effects of water on digital prints and find applied solutions to water recovery of damaged digital print collections. So there are more and more of these kinds of materials in institutional collections, certainly in workplace environments. What can you do when these objects are damaged through emergency? One of the most typical ways of sort of trying to postpone responding to wet objects with other forms of photographic processes, works of art on paper, library materials, is to freeze them if you can. So if you can freeze the wet objects, then you can thaw them methodically as you have the time and the opportunity to respond to them. But we don't know if freezing is a valid approach for digital prints or not, if it will induce other forms of deterioration that aren't worth that risk, or if it is worth pursuing that approach to prolonging recovery. So another area that we're looking into. What next? There are lots of things. We've been very focused on the storage environment in the past, predominantly because most objects in collections spend the majority of their life in storage, not on display or transport. But they're at greatest risk when they're on display or being used in transit. So I'd like to see us get into display. I can tell you from a museum practice, there's been a lot of work in recent years on creating sealed packages for all kinds of two-dimensional art to travel for loans to other venues, internationally, nationally. But these packages are developed based on sort of empirical evidence and experience, like when I did this, the object didn't cockle, or it came back in this condition. So we'd like to sort of try to create some typical sealed packages, run them through some accelerated aging with objects in, and see what performs the best. And also look at the cost of preparing these sealed packages. It can be very expensive to create a sealed package for every object, let's say in a 60-piece to 150-piece exhibition. And if it's only going to one venue, you go through all that expense, you do that prep work, you put it up for 3 months, you take it down, you take the package apart and put the objects back in storage, because you can't store them in frame packages. It's too much space, right? And so looking at just the materials involved in sealed packages. Maybe new monitoring techniques for assessing collections, something like those AD strips. There are other forms of pollutants that are harmful to specific types of collections. Can we create monitoring tools for collections to use to understand what the risks are in their storage environment in that regard? Mold prevention is related to this water emergency. I really would like to see the lab be more of a resource for cultural institutions post-emergencies in terms of how they can recover and reduce the loss of their collection materials. And then this one, IPI is always focused on the preservation of tangible photographic materials. And I think that there is a niche for us somewhere in digital preservation, but we have to define what that is. As I said earlier on, when Ali Khalid was talking about the permanence of different imaging technologies, we are making so many images and documents now that are born digital, saved digitally, and the preservation of those materials has completely different challenges than hard copy materials. Which is sort of where I want to end, and hopefully get you guys engaged in this discussion. So when I go back to the stick daguerreotype, I encourage you all to come on up at the end of the talk and see this plate firsthand. It's a beautiful plate. I'm guessing based on the hairstyle and the clothes of the women as well as the process, it's probably 1850 daguerreotype from our study collection. So this photograph is 170 years old, and the image Permanence is excellent. It's in great condition for an object of that age. If we keep it in proper environmental conditions, I don't take it out of the package and try to clean it, where there's any kind of surface, you're going to be able to access this image. You and I will be able to access this image in 170 years, right? It has good permanence, good stability, you know how to take care of it. Similarly, these silver gelatin prints. This is a late 70s silver gelatin photograph. You can see, and you'll have to probably come up and look at this more closely. Yellowing, right, around the exterior edge. This is bad processing. There's some residual chemistry left in this photograph. So all photographs are born in water. They have to go, when they're filamentary, they go through a developer, they go through a stop bath, they go through a fixer, they get washed
If that process, if any of that chemistry is exhausted along the way, the chemistry isn't right. If the washing isn't long enough, all the chemistry, the processing doesn't come out, and you see sort of overall deterioration from residual chemistry. But if they're well processed, again, excellent longevity because you've got silver, high quality paper in that varietal layer. I had to bring this one. This is a print of the image on the screen. This is a digital print. It's electrophotography. This is a nod to Chester Carlson's process was invented by Carlson in the 1930s. This is a contemporary print. It's about 10 years old. And there's an electronic image file of it on our graphics atlas. And the issues, again, sort of just to finish this up and maybe even provoke some questions, saving this image file long term in comparison to saving this print has very different issues. Any kind of image that's not human readable, it takes hardware to see it, software to open it. You not only have to preserve the image file, but also the software and the hardware to access it. All right, so the challenges there are different. It's a lot more than just what are the needs of the object. You can save an object. We have a wide variety of moving images. Imagine some of you, probably not many of you, some people, so I have actually a good colleague, friend who still has a VHS collection and a VHS player. But when that VHS player dies, how is he going to access that collection? He's going to have to find another VHS player. But as this technology becomes obsolete and gets replaced by others, you can see there's a need for emulation and migration of images to the newest technology so it can remain accessible. So the diligence and the discipline required to preserve digital collections is different. I wouldn't say that it's greater necessarily. There are a lot of research that go into caring for tangible collections, but very different challenges that maybe even some of you would be willing to tackle going forward. So that's my presentation, and I thank you for your time. This is my contact information if you guys have any questions, and just a nod to our funders. But I'm happy to take questions too. And please come and see the photographs. At least the daguerreotype. I don't know, have any of you seen a daguerreotype before? This is the first photographic process. It was introduced by Technical Society in France on behalf of Louis-Jacques Mondy Daguerre, and so announced in February of 1839. It was made sort of, there were no patents put on it, so people could begin making daguerreotypes all over the world almost immediately. Samuel Morse, as in Morris, was in Paris when this announcement was made. He was one of the first people to make daguerreotypes in America very soon after. So I encourage you to come and see it. It's a copper support plated with silver, and then a silver mercury amalgam makes up the white highlights. Very stable materials in a microenvironment. All of these things we talk about, well, you need a good environment. Very early on, there was an awareness that this silver is going to deteriorate if we don't do anything. So you rarely see daguerreotypes not presented in a package like this. And the goal was to create a microenvironment, protection from temperature, protection from humidity, protection from pollutants, protection from handling. When you see these in antique shops, oftentimes you might find scratches across the surface of the sitters. The actual silver mercury amalgam that makes up the white highlights of the image just sits on the surface. It's an extremely thin layer, and if you abrade the surface at all, even with the lightest, softest cloth, you can wipe that image layer right off. And oftentimes, unfortunately, people try to clean faces first. We don't do test areas. Always do a test area before you go for a face. So I encourage you to come and see this, again, just from the SETI collection. Okay. Any questions?
A question. Is there any place on campus that is certified to show nitrate film?
Oh, no. I mean, the Eastman Museum shows it with their nitrate festival every
Right.
spring.
On campus here, is there?
Say that again?
On campus here?
On campus here, not that I'm aware of. It's because it's highly flammable, and because you have heat with projection, it's a high risk. There aren't many places in the world that still show nitrate, really. I don't think that Eastman House can say, or Eastman Museum, I'm still making the transition, can say that they're the only place that still projects it, but initially, I think when they did start showing nitrate, they were one of the very, very few that will show it. Yeah. And again, nitrate, I've seen nitrate from the 1920s, 1930s that's in excellent condition, and acetate from the 1950s that's in horrendous condition. In terms of permanence, the nitrate doesn't deteriorate as quickly, but because it has these fire risks, and because when it deteriorates, so they're both cellulose monomers that either have nitrate groups substituted onto them or acetate groups. What happens is with cellulose acetate, the acetyl groups break away, they form acetic acid, you smell vinegar. It's called vinegar syndrome. If you ever walk into a film collection and it smells like vinegar, you have cellulose acetate deteriorating in that space. In contrast, the acid, so that is, some people are highly sensitive to it because it is an acid, but it doesn't have the same sort of health risks as nitric acid. You don't want to handle nitric acid, so that gummy mess of cellulose nitrate that I showed you, certainly not with your bare hands, not anywhere on your face afterwards. So there are other just safety hazards associated with nitrate that make people sort of very uneasy about it. But it can be more stable than acetate. It just has to be careful properly. Cold storage.
How unique is IPI as far as statewide, nationwide, worldwide in its mission goals?
Yeah, I don't think, it's not an exaggeration to say it's unique in that there's no other lab like it. There are other labs doing conservation science and conservation research, absolutely, but not with the level of focus that IPI's had. So people will compare us to the Getty Research Institute, the Getty. It's huge in scale, and they do a wide variety of disciplines, and so from painted surfaces to architectural structures to image material. And so in terms of sort of trying to tackle the similar challenges and similar needs in terms of collection type, IPI is unique in that regard, and does have a reputation internationally because the focus is always what are the questions that we can answer that will result in something that's very applicable or an easy resource to apply in the field, versus like, oh, well, it would just be nice to understand this better. We're very much focused on how do we help cultural institutions solve their problems? How do we help them preserve their collections?
You mentioned that there's 31,000 collecting institutions. Is that globally?
No, that's nationally.
Oh, just national.
Now, what you'll notice, though, if we went back to the pie chart, they included living collections in that survey. So botanical gardens and zoos, which we don't really have an impact on in terms of ours. So our audience is more the libraries, the archives, and museums. But I think of that 31,000, libraries, archives, and museums represent about 80% of those institutions nationally.
Because I know you reach international collecting institutions, that's probably immeasurable. I don't know how many hundreds of thousands you want.
I couldn't venture a guess, either. A lot. In all caps. Super. Well, this is my contact information. I'm at if you enter Gannett from the breezeway between Booth and Gannett, make a left and walk to the end of the hall. My office is just inside the doors of IPI. You're welcome to come by anytime. And if there are any opportunities for collaboration, let us know.
Should be coffee and cookies outside.
Oh, I have to get her to type up.